Okay, this lesson is to show you how to extend the Abstract Sprite class using the process of inheritance. This means that we can create a new class that has all the functionality of Abstract Sprite without having to rewrite the code or edit Abstract Sprite directly. The process itself is not the simplest if you're not fully aware of object-oriented techniques. So to get you started, what we've created is a framework class that you could use or reuse every time you want to expand with different behaviour the Abstract Sprite class. So you'll find in your project player.cs. Okay, this includes the class currently titled player. Obviously if you were working and changing this, you could change this to something else. And what it does is it has all the basic elements that you need to enable you to start a new class based on Abstract Sprite. Things that are important to understand about the process is that this is your class name. Okay, so you can modify that to be whatever you want it to be, but once you've done that, that's what you'll be referring to as your data type in your main program. What it's inheriting is specified by putting a colon and then the name of the class that it's inheriting. So Abstract Sprite is one of the ones that we could use. It's written by us, so we have a little bit more knowledge than maybe the rest of XNA. In order to make this work, we have to provide constructors that are similar to the ones in Abstract Sprite. We don't actually have to do anything with them, we just have to ensure that we can pass the parameters down to Abstract Sprite to make it function correctly. So in the example that we've got here, Abstract Sprite has got two lots of constructors. The first one was with animation and the other was just a single framed image as we used in the previous example. So all I've done is I've taken these from Abstract Sprite itself and made some minor modifications. The first thing is that the constructor needs to match the class name. The second thing is that the parameters also need to match the parameters for the Abstract Sprite. So this is why we've given you this as a template, because this will be consistent regardless of whether or not you are producing this yourself or whether or not it's something that's pre-written by me. So to clarify, the only thing you would need to change to make this work or to generate a new version of Abstract Sprite we can modify is to change the class name and make the two constructors match those class names. The other thing that I've included in here is one of the methods that we have been made aware of before, which is an update method, which, as you know, is called every screen update. We can also override the draw method of Abstract Sprite, and we can also create an initialize and a load content if we wanted to as well. But for what we're doing at the moment, we only need an update method because we're going to use it to allow us to put some controls on the sprite instead of it just being a static thing on the screen, which I'm sure, as games writers, it's the first thing most people want to do. Right, as it stands at the minute, if I was to run this, everything would be absolutely fine because we haven't actually created anything in our main program. So, in order to make use of player as opposed to Abstract Sprite, we would go into our XNA game, so the main game class, and we would do all the things that we did before in relation to creating an Abstract Sprite. So for a start, we can put player, okay, because this is our new class, and we can type into there a name for it, so we'll call it player sprite. Okay, just as we did before, everything's exactly the same because we've inherited all the functionality of Abstract Sprite. The next thing is then we can create an object based on it. Okay, so player sprite equals new player, and then it has exactly the same parameters as Abstract Sprite because we copied those into the player class. Okay, so very simple. This, just like before, the name of the actual thing that we're going to do, so saucer was the name of our asset, and the number of frames as last time was 15. Okay, and then you've created exactly the same as before, a player sprite. Now, after that, the only thing we find we need to do is exactly the same as we did before, which was in the game components. Add it. Okay, and at that point we have a functional program. What we don't have is anything to position it, or anything to animate it, or anything to control it. So the next stage is to, instead of filling up our main game with lots of code, we now have an update method built into our player. So whereas before, if we wanted to animate it, we would have had to put that in our main game, we now have an update statement that is just specifically for player classes and nothing else. So if you remember, there was a method next frame. At that point, that means that we would now find that this update method would be called for that player only, and it would animate our spaceship. Now admittedly it's up in the top left hand corner at the minute, but you can see the principle of what's going on. Now that's fine, that gives us the ability for us to now move all of our code that relates specifically to gameplay and somebody who wants to control that one instance. It means that we can now write that code in a separate little module. So let's make our sprite a little bit more responsive, because that's a bit boring having it stuck in the top left hand corner. Let's, for instance, make it responsive to the mouse, which isn't as difficult as it sounds. If you remember, Abstract Sprite had something called position, which allowed us to decide where exactly that sprite appeared on the screen. So if we modify those values and make them link up to where the mouse is, at that point our sprite will follow our mouse. So very simply, we're inside the player class already, so we don't need to use the variable name that represents what the player is. We don't have to call it player sprite. We already are inside the object, so we don't need to add that bit. So very simply, we just put position dot x, okay, so the x position of the sprite, equals, and the way that we access the mouse coordinates is just with mouse get state, and then if we just go for x, that will get the x coordinate of the mouse on the screen. Okay, so at that point our sprite has now become responsive to the x movement of our mouse. The obvious thing to say is we can then duplicate that, so that it also becomes responsive to the y position on the screen. So running our program again now, we now have a sprite that is completely responsive to where our mouse is located. You'll notice there's no mouse pointer. That can be altered within some of the settings in XNA just by changing the variable, but we'll leave it off for the minute because really mouse pointers are not particularly nice on the screen and we'll probably replace it with a sprite anyway. So that's quite useful. The other thing, obviously, as most gamers want, at some point you're going to want to be able to click or change something based on a button that's being pressed. So that's actually quite simple to do as well. And just bear in mind that there are two states for a button. It can either be pressed or not pressed. So we need to compensate for both of those things. So the change of state is quite important. So what we can do is we can write a very simple if statement, and we base it on the mouse state. So we'll work with the left button. And what we need to know is basically what button state it's going to be. Okay. So we have two options, pressed or released. So we'll change the colour of the sprite based on how the button state is. So obviously if you're going to write an if statement, you're going to have an if and an else. But we start with the if. So if somebody's pressed the button down, let's change the tint for that particular sprite. Okay, so we'll do tint, and then what we can do is we'll go for, I think we'll go for red. So colour, red. So we tint it red when the mouse button is pressed down. Okay, and then obviously if you release the mouse button, okay, so the mouse button isn't pressed, we need to reset it. So the normal options are white if you're not tinting it at all. Okay, so at that point we now have a mouse control that responds to the left button. And what we're doing is we're checking whether that left button is pressed. If it is, then we tint current sprite red. Otherwise we tint it white. And that gives us a very basic set of controls for our game. So if we run that now, you'll see that movement is still there. If I press the left mouse button and hold it down, it stays red. If I release, it returns back to its original colour. Okay? So that in its own right is quite a simple thing to do. It's not intended to be difficult for you to deal with. It uses very simple logic. Where you may get lost is in the fact that now you're writing an update method that is completely separate to the main game. So we'll just review that very quickly in terms of how this is working. So if we look at our game as a very simple program, we start by creating a sprite based on player. So because we've created that sprite, we've got a graphic in there, and we also have an update method that can be called. Nothing will happen, and that update and that moving and that displaying will not happen unless we add it to the game components. Okay, so when we add it to the game components, what happens then is that will then be called, its update method, its draw method, etc. will be called when the screen refreshes. Now, that's done automatically. It's part of what we call the game loop. But what people usually find quite confusing is the fact that when you look at player, there isn't a draw method. So a draw method is missing from here. So how does this thing get on the screen in the first place? Well, this is all because we've inherited from Abstract Sprite. An Abstract Sprite, I'll just open it up for you, has a draw method. Okay, now you haven't seen that because we've hidden it from you, but effectively here is where the thing's being drawn. Now that draw method is automatically called because it's inherited. So that means that player has all of these methods as well as the methods that we write in here. Now if you look, Abstract Sprite also has an update method. That update method has been overridden in player, i.e. we've added some more code, but at the bottom there is also base.update, and that means that the update method in Abstract Sprite will also be called as well as this one. So it will call this bit of code and then it will go and do the update method. So that's how we can add a simple set of controls to our player. For the next session, what we'll look at is how we can also control it through keyboard and also deal with the idea of having the mouse click rather than an up and down.